In this mini lecture, we start to look at what classes are and compare Java's classes to other data structures that are similar in the programming language C. And probably most of you haven't seen C, but Java was really derived as a response to C and C++. And it is useful to understand kind of why Java is designed the way it is, to just take a little bit of a look at the way that code worked in these older languages, such as C and C++. So the basic idea, one basic idea in object-oriented programming, and a way that an idea that goes all the way back to what was called structural programming in the 1970s, was this idea that you could define your own data structures. So imagine we have a data structure called a three-dimensional point, called like point3D, and this is C, not Java. Imagine that we have a data structure called point3D, in which you want to hold an x and a y and a z coordinate of this three-dimensional point in three-dimensional space. So obviously, in your programming language, you could just pass around x, y, and z, but it's not very efficient if you have hundreds of thousands or millions of points to have keep track of the x, y's, and z's separately. It's nice to be able to have your own data structure, which in this case would be called point3D. And point3D has an x and a y and a z coordinate. And then in your code, you can declare point3D and have that point3D have an x, y, and a z. So this is an idea of abstraction that goes back again to the design of languages like C and C++ in the 1970s. And this was a huge improvement over older languages that worked at lower level of abstractions, right? So declaring your own data structure is a way to work at a higher level of abstraction, because we abstract this idea of three variables called with x, y, and z coordinates into this idea of a single variable called a point3D. So this all works fine and was a huge improvement at the time these ideas were introduced. But one weird thing about this, one maybe disadvantage of this, is that the functions that work on these points don't necessarily have any relationship to the points themselves, right? So here I have a like if I'm trying to get a Euclidean distance from the origin. Right, the Euclidean distance from the origin is just the sum of the square root of x squared plus y squared plus z squared. Right, so here's a function where you pass in a point 3D in C, and what you get back is a distance from the origin. Right, but this code that works on the data could be declared anywhere in your program. So anywhere in your program, you could say get distance from origin, and you don't necessarily tie the methods that work on data to the data itself. And so one of the ideas for object-oriented programming is to more tightly tie the functions that work on the data to the data itself. So I want to do one small technical thing. This code actually works by putting data on the stack. We'll make a version that actually put things on the heap. And this is just to make the comparison with Java more direct, because Java puts all of its data on the heap. The stack versus heap thing, really not something you have to really worry about too much as a bioinformatics programmer. Again, this is going to be another case where we work at a higher level of abstraction. But just to make the code directly comparable, we'll change our notation a little bit in C, right? And so this is actually the somewhat bulky C code that you have to use. So you have to do a lot of manual work in C that Java's going to take care of for you. So we've already talked about this idea that in Java, the function is going to be more directly tied to the data, and that's going to be within a class. So this is sort of an introduction to what classes are. The other things that you have to do in C when you're doing this heap allocation is you actually have to keep track of how much memory gets allocated. So in C, this sort of awkward syntax that's in C, you have to say to C, figure out how big a point3D is, and then create that much memory for me to hold. And then I'm going to access this memory here. And then when you're done with this memory, you have to free up this memory. So you have to do manual memory management in C. And it turns out that people are this is a source of many errors in code. So people are just not very good at remembering to free up the memory. And it looks like this is really simple here. Like if you create this memory, you're going to remember to delete the memory. But once you get into hundreds of thousands or millions of lines of code, it turns out to be incredibly easy to either use this memory without allocating it, or to free it up before, or to forget to free it up. So if you forget to free it up, that's a memory leak. And if you use the memory without allocating it, your program goes into some unknown state. So in C, you have to do this low-level memory management. And a big improvement or a big difference between languages like Java and Python over languages like C is that you don't have to manually do this memory management. Again, as we walk through this code, in C, this creates some piece of memory, which is a point 3D. When you create it, X, Y, and Z are not defined. They're in some undefined state. And then you fill in X, Y, and Z. And now in memory, you have X equals 2, Y equals 3, and Z equals 4. When you can invoke this function on your point 3D, and then again, it's up to you to free the memory when you're done with it. Oh, this is redundant in this case because of course the program is about to end, so it doesn't actually matter in this case whether you free up the memory or not because the program is about to end. But in a larger program, it could matter a lot. If you forget to do this, you have a memory leak. So when we look at the similar code in Java, we see that there's some real differences. So one thing is that we don't have to do the memory management. We just say we want to have a three-dimensional point, and Java just makes a three-dimensional point. It figures out how much memory to allocate. We can use the reference to this object P to set the values X, Y, and Z. We can manipulate this, and there's no free in Java. Java is a garbage collection, has an automatic garbage collection. So Java figures out when we're done using this P, and then automatically deletes the memory. So when we compare the Java code to the C code, now Java is based on C. Java's kind of the people who Java in fact is programmed in C, right? So the people who designed Java knew C really well, and you can see there's lots of similarities between Java and C, but there are also some differences, right? So one of the differences is that this method works on these data, right? You don't have to pass in point3dp here the way you do in C. This method is part of the same class, right? This method just works on this data because it's all in the same class. And another difference is that in C, you have to manually allocate the memory if you want heap-based allocation, and you have to manually free the memory. But in Java, you don't have to do that. So Java figures out how much memory it's going to allocate, and it garbage collects this value P when P goes out of scope. And again, this seems like maybe a small difference, but this difference between having to manually manage the memory and not having to manage the memory is an enormous difference between languages like Python and Java and C. So it turns out that because people are so bad at forgetting to do this step, there's just whole classes of bugs that just go away when you move to a garbage collected language like Java. We're going to use these words over and over again. This is class point3d, right? It has these variables x, y, and z. The state of the object. The class is the definition of the data structure here. The object is what happens is the piece of memory that gets instantiated that actually holds this data. So this is a class, right? But P points to an object. You use a class to make an object with the keyword new. The state of our object is defined by these variables. So the state of the point is defined by the values for x, y, and z. You should be if you're reading Thinking and if you're using Thinking in Java as your base Java book, there's a lot of very lucid description about the object-oriented design of Java. If you don't know C, this comparison to C might not be that useful, though it's interesting for historical purposes. Right? But we want to get very, very familiar with using the syntax of classes and thinking about these levels of abstraction where we're going to reason about our program as being points rather than particular data points.